Hello guys, in this video we'll see the components of Kubernetes, right? Components means how the Kubernetes is working when you are deploying any application or you are deploying any pod replica set, how it is internally managing everything. If you'll see this slide, in the right side, right, you can see there are two planes are there. Kubernetes having two components, two planes. One is called your control plane or you can say master node. Another is called worker nodes or worker plane. Okay, if you'll see this control plane having many components, right? One is called your API server. I will explain what is API server, etcd and everything. What is control plane? What is the? It is having many components. One is called API, etcd, scheduler, controller, DNS Resolver. These are called the control plane. If you'll see the right side, worker node having Kubelet, runtime, proxy, CNI, service, PV. These are the worker node components. For the time being, it is little bit difficult to understand, but when you will do the practical, right, that time you can visualize more, you can experience more. Okay, first one is, now let me explain the control plane. First component is API server. This is API server is the central REST API that receives and solves all cluster operations. Okay, cluster operation means when you will planning to deploy something. Okay, when you are executing, kubectl is the command to do the operations on the Kubernetes. When you are executing any kubectl command, first it will interact with the API server. That means kubectl internally it is calling the API server. It receives the kubectl request, authenticate users, checks RBAC, validate YML, runs admission, then store accepted objects. This is the first API. This is API server. What it does? Its main component is its client is kubectl. When you are executing any kubectl command, the information first it will go to the API server. The next component is etcd. This is the database. Okay, and it is a key value pair database. Your information, your pod information, your Kubernetes information is stored inside this database. etcd is the consistent key value database where Kubernetes stores cluster API state. It stores Kubernetes API objects like whatever they be. In the last video we saw, right, there are many objects in config map, replica set, network policy. These are called the Kubernetes object. That object information stored inside this etcd database. Okay, and also this is also a control plane component. It is not a worker node component. This is a control plane component, etcd. It is called database. The next component is called scheduler. Scheduler means the scheduler assigns newly created pods to suitable worker nodes. Now here, it's Kubernetes cluster we are telling, right? When we are telling cluster, it is a group of servers. When you are deploying your application through a pod or replica set, whatever it is, then how the where that pod will run? There are many servers are there, right? That is decided by the scheduler. Scheduler assigns newly created pods to suitable worker nodes. Okay, how it helps? It checks CPU, memory, taints, toleration on the worker node or you can say worker servers. If everything looks good, then it binds each pod to a node. The next component, important component is called your controller manager. The controller manager runs control loops that makes actual cluster state match desired state. Controllers watch the API and continuously reconcile actual state back to the desired state. Suppose, just imagine in the last video we saw, there is a replica called 3. When 3 replicas are running, if one of the pod is down, then this controller manager automatically it will add one more node because it always looks the actual state and desired state. Okay, suppose actual state is 2 but the desired should be 3, then automatically it will add one more pod to that replica set. That is the task of the control manager. Also it is a control plane component. The next one is called Kubelet. Okay, if you see, Kubelet is not a control plane component, it is a worker node component. That means Kubelet is the node agent that manages pods assigned to its worker nodes. Whatever the scheduler assigned the pod to a particular node, then later, right, Kubelet is the agent who continuously monitors the pods. Kubelet watches pod assigned to its node, prepare volumes, networking, start containers, and report status. Once it is assigned, once one of the pod is assigned to a particular node, then the kubelet will take care of it. Kubelet will create its volumes, networking, start container, report status. That is the kubelet component. Kubelet is your worker node component. It is not a control plane component. The important part here is one more important component is called container runtime. Also, container runtime is not a control plane, or you can say master is not a master component. It is a worker node component. What is its task? The container runtime is the software that pulls image and runs containers. Container runtime, what it does? It is basically designed to pull the image from the centralized location. Image means your application image. When you run the application to a Kubernetes cluster, that image is not present in the cluster itself, right? It is present somewhere outside. First, what it does? It pulls the image. Who pulls the image? Container runtime. The container runtime commonly container D. Okay, I think container D is deprecated. CRIO pulls image and creates runs container for Kubelet. If you describe the pod, you can see the container image there. Next one is called Kube-proxy. Okay, what is this Kube-proxy? Again, Kube-proxy is a worker node component. It is not a control plane component. Kube-proxy maintains networking rules that let service forward traffic to the pods. I already told, right? Pod does not have any static IP. It is maintained by whom? Service. Service is the front door for the pod. Okay. The Kube-DNS, what it does, suppose one application trying to communicate with another application, then they have to communicate through the service name. If it is a name, you need a DNS server. So that DNS activity, who does? Your Kube-proxy does that DNS activity. A service has one stable IP, but traffic must reach changing pod IPs. If you also pod IP also changing, my request should reach to the pod. Kube-proxy program node networking rules, so service traffic forwards to the healthy backend pods. Okay, another one is called your CNI plugin. CNI plugin provides pod networking. Also, it is a worker node component. What it does? CNI plugin provides pod networking, pod IP, allocation, networking policy features. CNI plugins such as Calico, Cilium or Funnel create pod networking policy. Yesterday, in the last video we saw, right? There is a called network policy, ingress, egress. Okay, that ingress and egress is called a networking policy. That policy maintained by what? CNI. CNI can be, you can use Calico. It's a very, Calico I think it's a free also license version is there. Another is called Cilium or Funnel. Create pod networking and can enforce network policy. This is called your CNI plugin. Next one is called your CoreDNS. CoreDNS reserves Kubernetes service names to cluster IPs. So apps can call stable DNS name. This is the DNS service by internal DNS service by the Kubernetes. When one application is connecting to the another application, they have to use the Kubernetes service name. If they are using the name compulsory, they have to use the CoreDNS component. Okay, and CoreDNS, what is that? This component is called also control plane component. It's not a worker node component. What is its task? Its task is, you can see here, right? If I am creating a service, okay, suppose my service name is web-service, then this is the DNS name, web-service dot default dot service dot cluster dot local. This is the DNS name. This DNS name can be used by other application inside the cluster to access that application. Okay, this is about our components of Kubernetes. In the next video, when we'll do the practical implementation, you can there realize more what is these components. I can show you there. Once you are creating the, when you are creating the EKS cluster, that time these components will be auto created. It will become as a part of the cluster itself. If these clusters, these components are not available, then you can't make any, you can run your application successfully. These components are very important. Okay. Thank you.